This is the architecture of our SD-WAN. It's a three-layered architecture. The bottom layer is the data plane, and the middle layer is the control plane, and the top layer is the management plane, which contains the network applications. Our data plane contains SD-WAN edge devices and SD-WAN landing points. Our controller is in the control plane, and the network management plane contains our dashboard and the database. These are the components we have built in order to realize our SD-WAN. The first two, SD-WAN edge device and SD-WAN landing point, are data plane devices. These devices carry out packet forwarding in our SD-WAN. The third component is the SD-WAN controller. This is in the control plane, and it has visibility and maintains control over the entire SD-WAN. In addition to these three components, we have also built a simple protocol for the communication between the control plane and the data plane. This is the high-level view of our SD-WAN. We have three SD-WAN edge devices deployed in three regions. These SD-WAN edge devices are connected to SD-WAN landing points. The connectivity within the data plane is maintained using tunnels. And these tunnels create an overlay network on top of the physical network. The connectivity between the data plane and the control plane is maintained through the southbound channel. This is the SD-WAN implementation that we have deployed. Our SD-WAN data plane is deployed in virtual machines in USA, India, and Australia, and our control plane is deployed in virtual machines in the UK, and our dashboard is deployed in the UK as well. Here we have 4 data plane devices running. On the left hand side, we can see the edge device in India and the landing point in India. And on the right hand side, we can see the edge device in the US and the landing point in the US. Now here, the control is turned off. Let's try to ping our US edge device from our Indian edge device. As you can see, the ping is not working. This is because there's no controller running to push flow entries to these data plane devices. Now let's turn the controller on. Now we have turned the controller on, and you can see as soon as we turn on the controller, our ping has started to work. This is because now the controller is working to push flow entries to all of these data plane devices so that they can configure this flow. Now let's try to access a website hosted on our US edge device from our Indian edge device. And you can see the website here. Now let's try to initiate a download from the US edge device to our Indian edge device. As soon as we start the download, you should be able to observe how traffic flow across all 4 data plane devices ramp up. Now let's initiate the download. And you can see how traffic has increased across all of the data plane devices. And you can see the progress of the download here. Here we have 3 landing points running. Now let's try to observe how our SD-WAN can periodically switch the route between 2 edge devices by using these 3 landing points. Let's turn the controller on. Here we will use the alternating routes mode of the controller. With that turned on, we will ping our US edge device from our Indian edge device. And as you can see, the latency for these pings is changing. That's because the controller is periodically changing the route between our Indian edge device and our US edge device. Here our SD-WAN is running in the background. Now let's try to do a trace route from our Indian edge device to our US edge device. As you can see, the trace route command only shows 1 hop. This is because of the tunnels that we have used in our SD-WAN. Now we have turned our SD-WAN off. Let's do a trace route from our Indian edge device to our US edge device. As you can see, now there are multiple hops. This is because we have turned off our SD-WAN. So there are no tunnels working now. That's why we can see multiple hops along the way from the Indian edge device to the US edge device.